And we're live. You're listening to Interchain FM, a regular podcast about all things blockchain interoperability. I'm your host, Chango Unchained. Today, we're here with Ismail Kofi and Mustafa Al Bassam to learn about Celestia. The TLDR of Celestia is that it's a data availability solution for blockchain scalability. It's built with the Cosmos SDK and it's easily composable with different parts of the Tendermint stack. We'll get into more of the details later on for the next hour, but first, let's introduce our guests, Mustafa and Ismail. Can you guys please give an intro about yourselves and how you got into blockchain?
Mustafa, you want to start?
Sure. I'm Mustafa. I'm the CEO and co-founder of Celestia Labs. I guess my interest in blockchains kind of came about, I started following Bitcoin very early on in 2011, 2013, but I was genuinely interested in decentralized technologies even before I heard about Bitcoin. I was interested in things like BitTorrent, peer-to-peer file sharing systems. So I was always kind of generally interested in how can we make decentralized networks or software. And so when I heard about Bitcoin and Ethereum, that was naturally very exciting to me. And I kind of first really got deeply involved in 2016 when I did a PhD at UCL, focusing on layer one scalability. So I worked on things like sharding. We came up with one of the first sharding proposals. And Celestia also came out of my PhD research. I co-founded a company called Chainspace, which was acqui-hired by Facebook as part of the Libra or DM team. But I was the only researcher that did not join Facebook. And now I'm working on Celestia.
Yeah. Hi, I'm Ismail. My story is kind of similar to Mustafa's in the sense that I was like early on interested in like distributed systems and BitTorrent, and but the first time I really got into what's today crypto or like blockchain technologies was at EPFL, not as a PhD student, but like as a research engineer, where I collaborated with a research team on papers and written like prototypes for these academic publications essentially. And I continue working on, after that, I continue working on related stuff for which was like conics on the side, and did like an internship at Google at the key transparency team, which by the way uses Sparse Mercury, which we talked about before. And then I worked at Tendermint, so this is also where we overlapped, Django, and there I was mostly just like engineering. I worked on the crypto library a bit, on the Mercury, and on what today is called the KMS, and
The key management
later,
system?
yeah, exactly. And so that's the thing that like signs that holds the HSMs and signs the consensus messages in Tendermint. And afterwards, like after I quit Tendermint and then contracted for the ICF. So I was like kind of burned out and like almost tried to leave the blockchain space, but I actually stayed in the Cosmos ecosystem. Even like I just continued on working with the ICF and later on with Informal. And I met Mustafa at like several occasions, conferences, and he approached me at actually a hacker conference near Berlin and told me about Lazy Ledger back then. It's called Celestia today. And yeah, he asked me like, I want to join that project, and I was like, it was loud techno music around us, and I barely understood what it was about. So like, I looked at the paper and was like, sure, I want to join, and then yeah, we co-founded the company. That's how I ended up at Celestia.
That's great. How did you guys come up with this idea? Or I guess I would ask Mustafa about this.
Yeah, so the idea of Celestia, or as it was known at the time, Lazy Ledger, was something I was thinking about for a while. And the genesis of the idea came when I kind of started to ask myself the question is like, what is a blockchain? Like, what is the core components of a blockchain? Like, if you took Bitcoin and Ethereum and you stripped it back to its core components, what would you get? And would it be useful and practical? Because everyone takes for granted the way that Bitcoin is designed and the way that Ethereum is designed. So I started to think about like what are some alternative, like radically different design paradigms. And the kind of conclusion I came to was if you were trying to build the most basic or like most like simplest blockchain possible, the only thing you really need in a blockchain is two things: ordering and data availability. And if you have those two things, then you can pretty much build any application on top of that blockchain that you can today. And so at first, this was quite theoretical, but then I kind of realized this is actually very useful for developers that want to create their own blockchains. And by providing a very modular and simple kind of bottom layer for developers, developers can for the first time effectively build the upper layers very easily.
And just for context for our listeners, there's not so much understanding of how the blockchain layers work. So with the Tendermint lens, right? They've Tendermint has split up the consensus and peer-to-peer layers for the bottommost level of the stack, and then they've modularized it such that you could build a arbitrary state machine that runs application logic on top of the bottom layer, the peer-to-peer and consensus. So this is a wholly different paradigm than something like Ethereum and ETH Killers, in which it's an entire stack and it's a shared execution layer for different smart contracts. So how does Celestia do this a different way?
I can probably say so for me what was like immediately convincing and interesting about Celestia was that essentially what you said, that it Tendermint already decouples consensus from the state machine, like using what we call ABCI, application blockchain interface. And Celestia takes this just a step further. Like instead of the state machine now running like basically in process or even in a separate process, it is entirely a separate chain. It like the execution happens entirely somewhere else. So Celestia is basically this very basic layer that like also runs proof of stake and a base chain, but like the state machine is its own chain. So it's like the decoupling that you mentioned, but just a logical continuation of that and taking it one step further, essentially.
Am I understanding it correctly in that you are running the blockchain for other applications to not have to run their own blockchains and then just dump their data onto Celestia as a way to have data availability?
Kinda. So they can run what we call today a rollup. So it is like it is a blockchain, but they don't have to run their own consensus. So instead of today in like the Cosmos paradigm, if you want to launch a chain, you basically have to launch your own proof of stake network. And maybe like shared security on the hub will change that slightly, but like still it's like the same chain essentially. And in Celestia, you run a chain without consensus, but like use the consensus of the base layer for ordering, as Mustafa mentioned previously, is like the most basic blockchain that you can imagine.
Mm-hmm. Yeah. Okay.
So like the high level vision here, like put very simply, is to make it possible for anyone to create their own fully decentralized and secure blockchain very easily in minutes, like maybe with like one command line. Historically, that's not been possible. Historically, the best we've had so far is like you can deploy your own blockchain very easily using Tendermint with one or two validators. but you have to do a lot of work to actually try and find a bunch of validators to join your chain, or like pay, or if you use interchain staking, you have to like pay for the validators and so on and so forth. But what we're trying to do that, except from the box, from the outset, you start with a fully decentralized and secure consensus network by using Celestia as your consensus network instead of having your own validator set.
Yeah, so with something like interchain staking, you wouldn't necessarily need Celestia, or is it complementary to something like that?
So it's a different level. Well, it's similar to Celestia in the sense that interchain staking provides shared security, but interchain staking has a higher barrier of entry than using Celestia, because you effectively have to put some money into the system, and you have to kind of like in effect buy the validators, or like convince the validators on the hub to join your network. And ultimately, not every chain will be able to do that. Ultimately, only bigger chains will be able to do that. Like you can't, if you want to have a kind of ecosystem where there's millions of chains, for example, it's unlikely for all of those chains to be interchain staked with the hub, simply because those validators are not going to have the capacity to validate a million different chains. But what we're trying to cater for is really like a tail end of chains. Like if you want to develop a chain on a weekend, for example, and deploy it in a decentralized way, you can just do that very easily using Celestia, instead of having to, in effect,
You could even like deploy your own chain just ephemeral, like temporarily, like you just run it for a few days. And there's probably use cases for that as well, where you like just spin up a chain, let it do a thing like for some defined short time purpose, and then shut it down again. It's also very unlikely that this use case, for instance, like it's a very specific niche one, but like it's more like deploying a smart contract as like short-lived instead of a full chain validated by validators on the Cosmos Hub, right?
So this could possibly have a lot of value for hackathons, for example. If it's very short-lived, a 3-day thing, you could spin up your own, I guess, test blockchain with validators.
Sure, you could spin whatever you want. Like it's literally just very like lowering that barrier of entry essentially to deploy your own chain. So it's like the Cosmos vision, just a little bit more, that you literally can have billions or millions of chain at least.
That's great. And is this, how do the validators get paid? How do the economics around this work if it's just short-lived and free potentially?
Yeah, so I should clarify, like it doesn't have to be short-lived. Like we fully expect, obviously, like long-term chains to exist on the system. Like the key differentiator is, the way I see it, like interchain staking could scale to, let's say, thousands of chains. But what we're trying to achieve is to scale to potentially millions of chains, and the kind of the tail end of chains that have a very low barrier to deployment, like basically like similar to deploying a smart contract in Ethereum. You just like publish it and it's like whatever. But in terms of like the economic model, so there'll be the Celestia main chain will have its own validator set. The Celestia main chain is just a typical, relatively normal Tendermint proof of stake chain that uses the Cosmos SDK as a staking module. And the way it will work is if you have a chain and you want to publish your chain's block on Celestia, you basically pay for transaction fees for block space in Celestia, which would be calculated very simply on a per byte basis, and the validators would earn rewards from that.
So if I'm using Celestia and I'm a chain, that means I've already deployed my own blockchain, haven't I?
Well, it depends if your blockchain has already existed or not.
So it doesn't matter. It could be retroactive or it could be future looking.
Yeah, I mean, like you could deploy a new blockchain on Celestia, right? Like if you're deploying a new blockchain from scratch, you could just like from the outset use Celestia as consensus.
Okay, got it. So that takes me back to the data availability problem, which is I'm curious to know why Celestia wants to solve this piece of the blockchain technology space rather than any other problem. Why is this piece important to solve?
Because data availability is really kind of fundamental to the base layer of a blockchain. Um, it doesn't sound intuitive when I say that, but to understand this, if you consider a very simple blockchain that you can post any random data to, like imagine like a version of Bitcoin where anything goes. You can just post any junk data to the blockchain. How would you build a cryptocurrency on top of that? You could say, okay, let's build a cryptocurrency by posting the cryptocurrency transactions onto this blockchain where you can post any data to it. And what if someone posts an invalid transaction? Or what if someone posts a double spending transaction that spends coins that have already been spent? Then you could just say you can just have like an implicit client side rule to say let's just ignore all the invalid transactions and pretend that they didn't exist, even though they're on the chain. But in order to actually compute everyone's account balances, in order to know like what is Alice's balance, you need to go through every single transaction in the chain to know what everyone's balance is. But to do that, you need two things. The first thing is you need to know what the order of the transactions are. Like like if there's two double spend transactions, you obviously need to know which one came first to know which one is the real one. That's the first thing you need. And the second thing you need is data availability, which means you need to have the full and complete set of transactions on that chain. Because if you're missing one, then maybe in the case of a double spend, that missing one was actually the transaction that came first. So that's why ordering and data availability are kind of the core two components you need to build any kind of like blockchain-based applications that has a state. And but the data availability problem specifically, you might ask a question like, is like how can that transaction be missing in the first place? The reason why it could be missing is because a block producer might publish the block header, and that block header contains the Merkle root of the transactions, but the block producer might not actually publish the data behind that Merkle root.
So, just to contextualize this problem space a little bit more for people and dumb it down, data availability was something that was being explored in the blockchain space extensively as early as 2017. And it dates back to the early conversations in Ethereum, where people were talking about like plasma and scaling solutions where you could have safe exit games in case cross-chain transactions get censored. So for those of you who needed a refresher, data availability is basically a mitigation against block withholding attacks, which is what Mustafa is talking about. So as an example, if chain validators begin to censor or withhold blocks, it means that the blockchain, the side chain that is connected to the root chain is essentially corrupted, and then you can no longer trust it. So at that point, you need to move all of your money to the back to the root chain, right, and have like a safe exit game. So in the case that miners or validators are starting to behave maliciously, then you can no longer trust that it's working, and you need some sort of data availability solution because that's how you can ensure that the blockchain you're operating on is healthy and not completely corrupt. So transaction ordering transaction ordering is obviously extremely important because, as Mustafa said, if one were faulty and one were true and the true one gets censored, then the block producers get to equivocate. So that brings me to my next question about fraud proofs, basically. So from the vantage point of 2017, 2018, my understanding is that generalized state fraud proofs are not a thing, and UTXO fraud proofs, however, are. So can you help me understand how Celestia does fraud proofs? Is it UTXO fraud proofs, or are you doing generalized state fraud proofs? And if it is generalized state fraud proofs, is that possible in 2021 now? And can you explain how that's possible?
Yeah, we do generalized state fraud proofs, and it is possible. It's always been possible. Like it's kind of
Sorry,
interesting because
my understanding was that it wasn't possible because anything other than UTXOs was too high state to be able to process.
yeah, I mean that was kind of like the Bitcoin kind of thinking for a while. Like initially, it wasn't obvious. If you look at it from the Bitcoin kind of transaction model, it's not obvious how you do a generalized state transition fraud proof. So it's been quite difficult to convince, like especially people in the Bitcoin community, that it's possible. But if you look at it like, it's kind of funny because like even today I'm telling them like it's really obvious, but like they're like, no, it's not possible. But if you look at it from the Ethereum kind of account model, it's really simple. Like if you look at it, if you have an account-based blockchain, the way it works is that every block you have a commitment to the state. So like in Ethereum, it's a Patricia Merkle tree. In Cosmos right now, it's IAVL. Soon it will be switching to a SMT. So you have these state commitments that commit to the entire state and account balances of the entire kind of chain. And then every time there's a new transaction, the state root or the state commitment changes. So you kind of like if you imagine a system where, let's say, after every transaction, you attach the new state root for that transaction, after every transaction. Let's assume a system like that. Then what you've effectively created, or what you effectively have, is an execution trace. So you kind of got like this trace, this kind of like log of all the execution between transactions, because between each transaction you have the commitment to the state. And so if one transaction in that trace was invalid, it would be very easy to prove that, because the only thing you need to prove it is you need you need to send the transaction itself. So let's suppose you wanted to prove to someone that some transaction is invalid. Then what you would do is you would send the transaction itself. You would send the state root that came before it, the state root that came after it, and then you would send all the Merkle proof of all of the keys in the state that it accessed. And then whoever wants to check that proof can do that by executing the transaction themselves and see if it matches the new post state root. And if it doesn't, or if it's an invalid transaction, then that's proof that the transaction is invalid. Does that make sense? Or
Yeah, that does. And I'd love to see it operating in practice. So, if in production this thing totally works, then it completely mitigates the issues that the Bitcoiners were talking about. So,
I mean, there is some stuff in practice. Like I think Arbitrum 1, for example, is doing interactive verification games, which is kind of like a more complicated version of what I described.
And it's live and operating.
Yeah. Okay. All right. So, that's great. So Arbitrum is a competitor?
Not really. Well, so they're not necessarily a competitor. They're more like, Arbitrum, systems like Arbitrum and Optimism, they provide like rollup software to create rollups. So they're not competitors to Celestia, but they're more complementary to Celestia. You can create an Arbitrum rollup or Optimism rollup or even a Fuel rollup that uses Celestia as a data layer or as a consensus layer. Just like right now they use Ethereum as the data availability layer, but there's no reason they can't use a different data availability layer like Celestia.
Yeah. And so with other layer twos, how does Celestia's trust model compare? Because right now we've kind of seen that there's all these different bridges and they tend to work. So, how do they compare in terms of data availability and trust? Like, we'll just take the most popular chains, side chains, and L2s, for example, like Polygon, Optimism.
Yeah, so it's not so much that you would compare Celestia to the layer twos, but you might, for example, you could say like you can compare Celestia to, let's say, the Ethereum like rollup ecosystem, because like the idea is Celestia is kind of providing a similar function to what Ethereum is providing for those rollups on Ethereum, which is to provide the consensus and data layer. So it's like how does Celestia compete? Let's say the Ethereum rollup ecosystem. Like the main difference here is that Celestia is general purpose data availability layer. So what that means is Ethereum, when Ethereum rollups use Ethereum as data availability layer, Ethereum's data availability layer is not general purpose because Ethereum has an enshrined or consensus theoretical smart contract virtual machine. Because even though you have Ethereum rollups, you've also got the actual Ethereum state, which on-chain state with all on-chain smart contracts, which means in order to check which Ethereum chain is correct, not only do you have to validate the data availability of that chain, but you also have to validate or take an interest in validating all of the transactions on that chain. That makes it very unsuitable if, let's say, you just want to deploy a Cosmos zone as a rollup. If you deploy a Cosmos zone as a rollup using Ethereum as a data layer, you would have to include like the Ethereum virtual machine, for example, in your Cosmos zone, and like validate the Ethereum virtual, all the on-chain smart contracts on the Ethereum virtual machine, and make sure that they're valid in order to know which is the correct Ethereum chain. But with Celestia, you don't have to do that because we don't have an on-chain smart contract environment except just for the proof of stake module. So it makes it much more suitable as a more of a general purpose kind of data availability layer, if that makes sense.
So if we're comparing it with L1s, is there some value prop that Celestia has over something like Polkadot or ETH2 architecture?
Yeah, so I mean, compared to Polkadot, kind of the way I see Polkadot is Polkadot and Ethereum 2.0 sharding are very similar, because Polkadot kind of claims to be doing something similar to Cosmos, which is kind of creating this multi-chain ecosystem. But the security model of Polkadot is such that if you go to the main relay chain, if you want to connect your parachain to the relay chain, there's a limited number of execution slots on the Polkadot relay chain, because in order to have shared security in Polkadot, all the Polkadot main chain validators have to take an interest in validating all of the parachains. So there's a limit. So you have to like auction off parachain slots, and there's only so many parachains can connect to it. It's kind of like if you had Cosmos but had interchain staking enshrined, so that you're only allowed to create a Cosmos zone if it was interchain staked. So that's why I kind of like Cosmos so much, because it's the beauty of Cosmos is that it's extremely modular, and so like nothing is forced or enshrined on you. Like you can just create your own standalone Cosmos zone, and you can do whatever you want for shared security, or even have no shared security.
Yeah, but I want to talk about the value add that Celestia has for the Cosmos ecosystem, because what we did was we began with modularization and not kind of like forcing people to adopt shared security with Atom, for example, or any other Cosmos coin that has security benefits with it. And you're saying that, well, there's a finite amount of uh, zones in Cosmos that could benefit from shared security just because of the capacity of the validators. Um, and that's kind of like Polkadot, except in Polkadot, it's, I would say they've kind of artificially capped it, right? For some reason. But Celestia can kind of extend it at the perimeters, if at the peripheries.
Yeah.
Sorry, if I'm understanding that correctly.
Yeah. So there's also a technical reason why they're only limited like execution slots in Polkadot is low. So because like execution is expensive, like state execution is expensive. And that's why in Celestia you completely remove that from the main chain and move it to the execution layer, like to the rollup chains essentially, or like to the client-side execution completely. So that removes that limit. And even like in interchain staking, it's similar, right? Like the validators on the main chain, they validate the state of the I think they're called baby chains in Cosmos, right? Like in interchain staking. So that's not the case in Celestia. The main chain validators, the only thing they do is they validate that tiny portion of state that is relevant to the main chain and nothing else. And they make sure that the blocks that are published by rollups on the main chain are paid for, and that's it. And they're paid for like on a user, like on when you as if you submit a transaction. It's not you have to win any auction or anything. You can just do it. Don't
Can
ask
you,
anyone.
yeah, can
Sorry.
you give us a primer on rollups and how that ties into the greater Cosmos ecosystem once you have Celestia? And also, how do you do rollups in Cosmos? Are you building a module for that, or are you extrapolating that to like other, chains that use Celestia in the future?
I can briefly talk about the second version, how you do it. So essentially, technically, how we do rollups for the Cosmos SDK is, imagine you remove Tenement from the lower layer and replace it with something that just aggregates transactions and publish them aggregated as a block onto Celestia. And that we call that Optimint currently, but it's a very, very simple project, like it's very simple, like software artifact that just aggregates transactions and adheres to the ABCI interface, like the Tenement side of it, and that's about it.
So, if I'm understanding correctly, somebody who wants to build a Cosmos chain without Tendermint basically goes into the Cosmos SDK, it plugs in Optimint, and it is able to spin up an application using Celestia.
Yeah. So how in practice, how it ideally would work is that you don't have to plug it in yourself, but like it would come scaffolded. Like there would be some scaffolding tool. Like imagine Starport. You can choose, oh, I want to build like an application on Celestia, and then you choose that, and it automatically replaces a few imports in on the SDK side. And theoretically, you as a developer, you don't have to care about this at all. Like it happens in the background. There's like the templates and for the scaffolding, they change, they replace the imports, and that's about it. And like from the deployment perspective, how it could look like is you literally could have like a button somewhere saying like you click on, even on a cloud provider, you could click on like, yeah, I want to deploy a Celestia chain. You click a button, you deploy your Go application or whatever language, and then you run that, and then you have an aggregator, and then clients can join the network, and that's it.
Okay, so this is reminding me about White Block. So the service that White Block provides is this sort of distributed network of validators that you could just spin up really quickly and easily, and it uses data centers around the world, and that's the kind of value prop that it has. So Yeah, I see that as definitely valuable in that you're lowering the barrier to entry for people, application developers, to deploy a Cosmos SDK app. However, what does that do with the trust model and decentralization? So, do you expect a lot of these nodes to be on like AWS, DigitalOcean, more like that, instead of kind of distributed around the world in like data centers that are, I don't know, robust against like environmental catastrophes, for example?
So I mean, the beauty of rollups is that they're trust minimized, which means that whoever is operating that rollup does not have to be trusted for either safety or liveness. So like, it really doesn't matter where that rollup is being hosted. It can be hosted like on EC2 or wherever, but it doesn't matter because the security for that rollup is not coming from the operator of that rollup. It's the security for that rollup is coming from the Celestia data availability layer. So what we're effectively doing here is we're trying to envision a world past committee-based security assumptions. So instead of like creating a chain and having committee-based security where you have to trust like 2/3 of validators are honest for like, let's say, the IBC bridge to be secure or for the chain to be secure, we can effectively replace that committee-based assumption with like a fraud or ZK proof, which relies on more of a honest minority assumption. So that it really doesn't matter where that like who is operating the rollup, because you don't need to trust them.
So if it was only single aggregator, like a single operator in the cloud, the only thing they could do, they could like not submit the block and censor everyone, but you could like easily spin up another one, or you could still have like a committee of those and then go round robin. Or yeah, I mean, the beauty is that it's very, very pluggable, and due to that trust assumption, you like the trust minimization, you could still do what I said before with like the one click and cloud deployment. It would still be secure. You would still need not to trust anyone, but it doesn't have to be like a single aggregator, obviously. And we're not building it that way either. Like Optimint is already I mean, currently it's just a single aggregator, but like we are planning to have like a round robin leader selection, for instance. So, and everyone can be an aggregator. Like you can choose as a client and a network, you can choose to be an aggregator. You can choose to be like a light client. It's completely up to you. So, yeah.
Yeah, I mean, in the original ZK rollup proposal, like anyone is allowed to propose blocks. Simple as that. Like anyone can be an aggregator.
All right,
Yeah,
so
but what the most ZK rollups, what they do in practice, at least right now, I think there's only a single aggregator, which will also change in the future, I guess.
so if I'm understanding this correctly, an aggregator is basically equivalent to a block producer.
Yes.
Okay, and so it's basically permissionless entry. You don't need to be signed in order to become a validating node. Anybody can become one, and you could spin up as many as you want.
Yeah, I mean, like it depends on how you structure it, right? So, like on a simple level, you can just make it so like anyone can be an aggregator. But the problem with that is that there's potential denial of service issues. Like, what if someone spins up like 100 aggregators and posts 100 fake blocks? Like, this fake blocks still wouldn't be accepted because you can easily generate a fraud proof for them. But it's still kind of a pain, right? So you can still introduce some barriers to being an aggregator. Like you could say like you can only propose blocks if you like bond 10 coins, and if you produce invalid blocks, you lose your coins. But it's still permissionless because there's no like whitelist or blacklist of aggregators. Like anyone that bonds those coins can participate, just like anyone who can stake, in a proof of stake network can produce blocks.
But in In BFT proof of stake, there is a finite amount of slots that are available for validating. So in this case, how is it different?
Yeah. So I don't think there will be I don't think in this scenario that there will be a finite amount of slots, because there's no communication. There isn't like this O(n) squared, communication complexity between aggregators, right? It's just like aggregators just post the block on the chain, and all the aggregators and all the other nodes download it. If it's valid, it's valid. There's no consensus between the aggregators. It's like it's just like whoever posts the valid block, it's valid. And the consensus happens on the Celestia main chain, which is where the ordering of the blocks happens. So yes, on the Celestia main chain, because we're using Tendermint BFT, you only have like 200, validators or whatever. But with rollups, there isn't this communication complexity between aggregators. So I don't think there will be this limit.
Understood. So let's move the conversation to sharding, because that's one of the hottest topics right now with ETH2 coming along. How do you do sharding?
So
and what's the architecture with this sharded rollups construction?
So by sharding, do you mean like if you have like a set of rollups that communicate with each other, or like more generally?
Or, well, generally, or no, how does Celestia do this? And how does Celestia enable sharding?
So like Celestia itself isn't sharded, or at least like the initial version, won't be sharded. It's like our kind of model for this is, so like I guess you have two different layers of sharding, right? You can shard data, or you can shard execution, and on top of that you can also shard execution. So like if you imagine the original ETH 2.0 roadmap, it had like full sharding. Let's have like sharded execution shards where all the execution happens. They abandoned that, and said let's just not shard execution, and let's just have data shards, which are like all the shards only do data availability but no execution. And we don't do either. We're just like a non-sharded blockchain, with one data shard. But the way that we kind of generally envision execution scalability is we think that you can implement sharding on the execution layer, which is on the layer above Celestia. So like you could implement Ethereum's 2.0, like phase 2 or whatever execution sharding protocol on top of Celestia if you wanted to. Similarly, you could create if you had like a really popular Cosmos zone, for example, and that Cosmos zone was so popular that a single chain wasn't enough to process all the transactions. You could like split up that zone to 5 zones, and let's say those zones are rollup, and have this rollup communicate with each other. So you can have execution sharding, but the execution sharding is not enshrined on the base layer. It's kind of like a layer above that.
Got it. So we have horizontal scaling in practice, is what you're saying.
Yeah,
fantastic.
on the execution level. But I mean, that's what Cosmos, like that was the original idea of Cosmos, right? It's like, let's have heterogeneous sharding. Like Cosmos itself is basically heterogeneous sharding, right? Because anyone can create their own zone, but those zones have different levels of security.
Well said. So that's great. And thank you both for the great introduction, high-level overview of Celestia. I want to take things a little bit more personal. So I wanted to know more about your guys' background. I was listening to the Epicenter podcast, and I found it really interesting about the, I guess, your Cypherpunk beginnings in crypto. So that's always something that's really fun to hear about, and I want to know about that.
Mine or Ismail's.
I think your story is much more interesting. You should go.
Yeah, I mean, yeah, sure. So I mean, before, when I was like 14, 15, I was I was involved in various kind of online hacker groups, doing very illegal things. So I was
Such as
so I co-found
like dark web stuff.
No, it's like we hacked into like a whole bunch of stuff. Like, we hacked into we hacked into the U.S. Senate. We hacked Fox. We hacked like Sony like 7 times. This was like back in 2011. And so it was like there was like a group of 6 of us, and I was arrested for that.
Oh, was
when I was
this
16.
anonymous? As anonymous?
Yeah, some of it was anonymous.
Nullsec
Yeah,
is the group.
yeah.
I'm
So there was. So I was involved with Anonymous, but there was also a group called Dulsec, which was kind of spun out of Anonymous.
Well,
And
what's the history behind that?
well, so the idea was, when I first got involved with Anonymous, the idea was that people were doing all of these activities and hacks for kind of political reasons. So it's like, I think I was trying to think.
Were you part of the group that started Anonymous, or you joined early?
Oh no, like Anonymous was like, I was like 5 or something when the idea of Anonymous came about. No, I didn't start Anonymous. No one knows who started Anonymous because it's anonymous. But because the idea of Anonymous was like you would do stuff for political reasons. So, like for example, like we hacked during the Arab Spring, we hacked into the Prime Minister of Tunisia to put up like a revolutionary message, or like we hacked U.S. military contractors to expose what they were doing. But then like
And
so
here
we
we
had like
thought it
this.
was Russia.
Yeah, no, we actually discovered like the U.S. Kind of Department of Defense, I think. Well, no, it was a different U.S. department was like hiring this company called HBRE to, well, not hiring this company, but like they were trying to like do astroturfing, they were trying to solicit software to do astroturfing, which is like creating a bunch of Twitter accounts to like, so basically exactly what they accused Russia of doing, but they were doing it themselves. But
Well, I mean, that's an entire business model,
Yeah.
and it's prevalent everywhere. And on Reddit, on Twitter, it's still
yeah,
still a
exactly.
huge thing.
Yeah, and it's not Russia specific. It's definitely. I'm pretty sure it's very CIA specific. Like the CIA is the expert in this stuff. So it's kind of funny that people
Not
think
only the CIA, but the intelligence agencies of all of the major governments, right?
Yeah,
Mossad
exactly.
included.
Yeah, like we discovered that GCHQ, which is the UK version of like the NSA, had a bunch of like fake online services. So like they had this fake URL shortener, and so like they were encouraging like various activists to use it. So like when you click the link, they can see your IP address, and they had like a bunch of
Oof.
fake Twitter accounts and stuff like that.
Honeypot.
Yeah, exactly. But so we had this like little hacking channel where people were discussing like different hacks or like different vulnerabilities in websites they discovered. But the issue was like a lot of the kind of hacks that people came up with were kind of like very not politically related. It's like one day someone found like a vulnerability in Fox, and they accessed like the X Factor contestants database. And it's like, why do we need to hack that? Like, what's a good reason to hack that? There's no good reason to hack that, right? Like, there's no political reason to hack that. So like, I didn't want people to be like releasing those kind of databases or hacks like under the banner of anonymous, because I would feel like it would be polluting the kind of political like aims of anonymous, like as a kind of political kind of group. So we recreated
You're also
this.
targeting civilians, which gives it a bad look.
What do you mean? What do you mean? Oh yeah, Fox.
Like
Yeah, sure.
doxing
But
normal.
yeah, exactly. Yeah. So like we just like it's just releasing databases on in ordinary people. So we created this alternative kind of like banner or group called Dulsec, where we said like if you do hacks that are not politically related, just release it under Dulsec. So then you don't have to like pollute the banner of anonymous. And so like we came up with a lot of hacks for Lulsec. Like as I said, we hacked Sony like 7 times, and a bunch of like Fox, PBS, the US Senate, and a bunch like there's a whole list of them. And like people for some reason people really enjoyed it. Like the Lulsec Twitter account had like 300,000 followers, It was like
I
people
was
were
I
waiting.
was one of them early in the days.
Yeah, so it's like people were strangely really entertained by this like hacker group on Twitter. Like it was like who are they gonna hack today? Let's like he's like what's gonna happen today? It's like people kind of like to follow like organized crime on Twitter, the same way like they might follow like a hashtag for the release of a new movie.
Well, there's kind of this feeling that they're partaking in peaceful, civil disobedience, because that's part of the reason why people are attracted to Snowden and WikiLeaks. It's because it's kind
Yeah.
of, like crimes against the man.
Yeah. So like even though DLSEC was never meant to be politically oriented, like I think in the end it kind of became politically oriented because like the whole idea of DLSEC was like we'll just hack whoever is funny to hack. But it turns out what's funny to hack is also what's just to hack. Like it's quite funny when like a big corporation that deserves it gets hacked, but it's not really funny if like random people that don't deserve it get hacked.
That's right. So what did you find?
Well, with HP Gary, that was anonymous, but with HP Gary, we kind of like really like leaked this entire like email database of this US Department of Defense contractor. Like we found out they were working with Palantir, which is like this big US tech company to
It's
like
Peter
create
Thiel's
this.
company.
Yeah, exactly. They were working with Palantir with like all kinds of like dodgy proposals. Like one proposal was like um how can we kind of disrupt WikiLeaks? And like one of the ideas they had for that is like we should blackmail American journalists that are reporting on WikiLeaks, as an example.
Wow.
And
I'm
then
speechless.
yeah, but a lot of the other stuff was just kind of like more wasn't so much like revealing information but kind of like just doing funny stuff like we hacked the Westboro Baptist Church, for example. I don't know if you're familiar with the
Oh, the
Westboro Baptist
West.
Church. Yeah, yeah.
No,
Like
sorry. Go on. You could contextualize it.
yeah, it's like we hacked them on my friend Jake did like an anonymized radio interview with them, and the idea was like we would like hack them in the middle of the radio interview, so like we would like deface the website. You can see that like that's got like 4 million views on YouTube.
What is it called?
Just for like anonymous hacks Westboro Baptist Church.
Perfect. Thank you.
Isn't there even like a documentary or something about that? Like, no?
There's documentaries about Anonymous and the Westboro
Yeah, and
Baptist
I think
Church.
that includes that. Yeah, I think
Were you
anyways.
in that documentary?
No, I don't think so. I think I was still arrested at that time. Well, it was a very US specific documentary. There was no, yeah.
Tell us about your arrest.
It was pretty uneventful. Like UK arrests are not very eventful. It's not like FBI arrests where they have guns blazing. It was just like a bunch of plainclothes police officers. They knocked on my door. They kind of rushed into my room, and they just searched like my whole room to find like evidence. And they took me to a police station and interviewed me, and then they released me the next day.
And so they wanted to arrest you for alleged hackings that you've now admitted to on air.
Yeah. So at the time, it was like, well, I was arrested. Well, I've already pled guilty to this, so I can talk about it. But yeah, originally there was 80 charges, so like they had to read out like every charge one by one. It's like they did like each hack was one charge. Eventually, because originally like each charge was under the Computer Misuse Act, so they had to actually prove that I actually hacked it. But eventually they condensed all those charges into 2 charges, which are conspiracy charges. It's a lot easier to prove a conspiracy charge because you just have to prove that that you talked about doing it, rather they don't have to prove that you actually did it, which is a lot easier to prove.
And how does this history tie into your current dealings in crypto?
I mean, I don't know if there's a kind of direct relationship to that between that.
But
between the
there's a
hacking and the
there's a
crypto.
there's a sentiment of crypto anarchy in there.
Yeah, I mean, there's there's a sentiment of cypherpunk. But I mean, I don't know. Is hacking inherently? Yeah, I mean, I guess like the political ideals are similar, right? Kind
Well,
of
in
like
that it's
saying,
free
yeah,
speech to do that.
yeah, or like trying to kind of, uh, you know, bring certain powers back down to some extent, or redistribute power. Exactly, like you can redistribute power by leaking information. Like as a hacker, releasing emails and get people investigated, or get companies that are doing bad things investigated. In crypto, you can also redistribute power with decentralized applications that remove power away from centralized middlemen.
Exactly. So, why did you approach Ismail to join you on Celestia?
Well, I was familiar with his work before, so like I know he did some ghost, he did some like Go work with verifiable data structures. He worked on this project. He worked at Google on verifiable data structures and related. There's a project called Connix and Trillion. And the most important thing was like he was a Tendermint core developer, and it's like at the time like Tendermint, well, even to some extent it's even at the time it was like the only production ready proof of stake system. Like now we have Substrate, and to some extent Avalanche's proof of stake code. So like the only option at the time was to build it on top of Tendermint. And since Ismail was Tendermint core engineer, he seemed like he would be good as a CTO.
And what's the developer experience using Tendermint proof of stake versus Avalanche version of proof of stake versus Substrate's version?
So we're not. I mean, we looked into Substrate a bit, but like we did not try to build it on Avalanche or on like Tendermint, right? Like, so as far as I can say, the Tendermint is good if you don't want to change a lot in like internals inside of Tendermint, right? If you just want to change your state machine, that's totally fine, and that's probably I would say like the best out of the box experience. If you want to do changes in Tendermint directly because you want to change details like in the header or how the data is merkleized and stuff like this, Tendermint is a bit limited to some extent, right? It's not made for this. It's rather made for like, here, take this and build like a state machine on top. I have no experience in building on Avalanche. I cannot say anything about that. Substrate's consensus is, I would say, due to its nature, just a bit more complex, right? It is like Tendermint, but like block production can happen like before, and then you do essentially Tendermint, slap that on top, or like something like Tendermint, you slap that on top. I also never built any big project on Substrate, so I cannot talk about the developer experience there.
Got it. Okay. Well, thank you both so much for coming on. This was a great and insightful overview. And we're coming up on the hour mark, so we will go ahead and close. Do you guys have any socials that you want to share here now? Where can people find you? How can people learn more about Celestia?
You can go to celestia.org and you can follow us at celestia.org.
And what about your personal socials?
You can find them in the tweet. You can find them at Chango's tweet. Mine is difficult to pronounce.
Fair enough.
Yeah, mine too.
We'll link these in the show notes so that our listeners can easily find you too. And thank you so much for thank you for coming on Interchain FM. We are doing these interviews with guest projects that are primarily building in the Cosmos ecosystem, but largely in blockchain interoperability every Thursday, sometimes every other Thursday on Twitter here on Twitter and YouTube Live. So next week, we're talking to Persistence, which is another Cosmos ecosystem project. They've recently deployed P-Stake, which is an airdrop to both Atom and XPRT holders. So tune in for that next Thursday, and I'll see you soon. Bye.
Awesome. Bye-bye.
Bye bye.